take a look at this brain versus body weight example. Now, I want to pull in this data set called brain and body weight .csv. It's a .csv file, meaning it's a comma separated value file. Let me show you what can go wrong here. In fact, what if I tried read.table here on this CSV file? I get some kind of an error there, and there's a lot of other things that can happen too if you don't read the table in right. Sometimes it might even pull them in anyway, or do something strange, or it might include the commas that are in the file where you don't want them. So it's important to actually let's get rid of all that nonsense and just use read.csv. You got to use different commands, it turns out, sometimes to read in certain kinds of data files. Usually we're reading in text files. This is a comma separated value file, and it's got a header, so I'll denote that with header equals true, and there we go. So now if I do head of data, I'll see what's going on here. So I've got a bunch of animals in the first column, and I've got their body weights. I think their body weights are actually in kilograms, so it's really body mass and brain mass in grams, I believe is what it is. We want to see if there's any kind of a relationship between these variables. By the way, when you read in this a file, you can also always check to see what kind of a class the object is. Is it data frame? We like data frames generally. They're pretty resilient to all kinds of operations. Sometimes you need to turn them into matrices, though, if you want to treat them as matrices. So we'll talk more about that later, especially when we get to matrices. But so anyway, so let's make a plot of brain weight versus body weight. And by weight, I mean mass. And by mass, I mean weight. Okay, hope that's all right. All right, there doesn't really appear to be anything linear going on here at all. It's just kind of messed up, right? Well, let's take a closer look at what's going on here. You know what? Maybe I'll. One thing you can do is use this text command, and text. Put in your your y variable, your x variable, I guess. Is that right? Or vice versa. Your x variable, then your y variable, and then you can actually label the data points. Okay, I'm going to use the values in this animal column to actually label the data points, and these have to do with positions or colors or something. I don't really know. You can adjust them and see what happens. But if I do that, you can see, oh, okay, everything is mashed up here. I'm not sure what all that stuff is, but hey, look, this is an African elephant, this is an Asian elephant, this is a human. This is actually, I think this is actually a brontosaurus. It's cut off over there. So that's kind of interesting. I tell you what, I may want to make another window in a second here, but I tell you what, let's take a look at the data, all the data there. Yeah, look at these last few observations. We've got some big ones here. We've got cows and horses and giraffes, Asian elephants, African elephants, Triceratops, Diplodocus, and Brachiosaurus. Brachiosaurus was a humongous creature. These things haven't been around for like 65 million years. Brachiosaurus maybe even longer, maybe more like 100. I'm not even sure. Anyway, so we may not even want to consider them. So I tell you what we'll do is I'm just going to get rid of these last ones, these including the elephants, because they're sort of outliers, I think. If you look at this the graph there, and so one way I can do that is, I'll just type the name of new data set, data.mod for modified, okay? And in that data set, I'm going to store what I had in data, but just the first 60 rows 1 through 60, comma, and then leaving the column indicator space blank to indicate all columns. And then there we go. So now if I do data.mod, it's exactly what we had before, and it still resides in data set, but it's just without those last 5 entries. And so now maybe I'll plot, I'll redo my plot there, and I'll even add those labels again. Okay, like so. Now what do we have? Now we see a sort of a more of a trend, kind of, there sort of seems to be a cluster down here and then moving off to the right. And then we have these people. Who are these? For their body weight, we have much larger brains than a lot of these animals. So maybe we want to get rid of the humans, okay? Just get rid of them, but in a second. For now, let's get do a linear regression and summarize the results of that regression, and look at our R-squared value. It's not very good, right? It's 42%. I can drop a line on there if I want to, and maybe even check out the I could store the residuals and then make a plot of the residuals versus the body weights. Okay, so I'm just going to paste that like so, and la-di-da, check this out. Okay, so here's a plot of my residuals versus the body masses. Certainly this one is an outlier. Okay, I imagine, especially if I standardize these residuals, then I would see that there's really kind of a problem here. So I'd want to throw this guy out. I think this is the residual corresponding to the humans. So I'm going to tell you what, I'm going to take out the 50th row. The 50th row is the one that corresponds to the humans, right? I know that if I do data or even data mod, look at row 50. Those are the humans. Okay, so what I'm going to do is just you can. I'm going to store this in a new data set called just animals. Okay, and it's the data mod data set, but taking out the 50th row. That's what that does, and then I'm going to include all the columns. Okay, so I'm leaving my data sets called data, or data frames specifically. I'm leaving my data frames called data and data mod intact. Okay, so I can always go back to those if I want to, and now I will make yet another window, and now let's do linear regression and get the output there. Our R-squared value has now increased tremendously. It's about 79%, and let's now plot the brain masses in grams versus the body masses in kilograms. And I'm not labeling the graph. I'm dropping a regression line on there too. I'm not labeling it just because I'm trying to move through this kind of swiftly, but you can see that there's much more of a linear trend there. Okay. Now I'm going to go to residuals here and store those. Remember, I can do it a couple of different ways, or I can also do it like this. It's out residual. Okay, that stores my residuals. Residuals. Okay. Okay. So there's the first 6 of those. I can plot the residuals versus the body masses, like so. Okay, and I can also drop a line on there if I like, just to help compare, and drop labels. Okay, so I'm still seeing a lot of it looks like the residuals are kind of all over the place. I'm not seeing that nice sort of uniform variance, or what, homogeneity of variance across there. So that's kind of a problem. What we'll see is that we can actually take a data transformation of these variables, and that'll solve things. That'll solve a lot of our problems. Also, the linearity is not doesn't seem to be present.